chapter 12, quiz number 3 from this chapter. It's about inventory. Okay. Why inventory is important in operations management? If we have inventory, then we need a space, right? And then we need an employee, worker, who can store, and time too, right? So that is kind of cost. How can we reduce cost? If we get rid of the inventory or less inventory, then we need less space, right? And then less time move and less number of worker, right? So finding optimal inventory level, save cost, make it cheaper, right? So inventory management is operations management. Make it cheaper, right? Inventory, start of any item or resource used in an organization. If we are manufacturer, we need material, something, right? And also something material, raw material, such as wood, iron, rubber, and so on, and component supplies, and so on. They are, work in process. In process, something part move. They are work in process. They are also inventory, and final product. They are inventory. Inventory. Then why we need inventory? Maintaining independence of operations. If we produce different types of product, because I know there are Hyundai and Kia near here, so I example Hyundai, many example. Hyundai produce Elantra and Sonata. 1,000 Sonata, 1,000 Elantra, and so on. Schedule like that. But if there is inventory, enough inventory there, then they can schedule change or make a different one, right? So inventory gives some independence. Then variation, demand change. Then inventory, if we have inventory, then demand high, then we can meet that change. And the flexibility, same story. Independent, then we can schedule change. And safeguard. This one is the same as the meet the variation, right? Same story. And then take advantage of economic purchase order size. Buy one by one, regular price. Maybe we buy many, then we can have discount, right? So if we have inventory area, enough space, then we can buy more. Then we can buy cheap price. Inventory cost, there are 4 types of inventory cost. Holding cost, if we have something inventory, then such as handling, insurance, and so on. And setup cost, when we produce different type, then we need a setup time, that is setup cost. And then ordering cost, when we order, then something preparing time and cost, ordering cost. And shortage cost, it says opportunity cost. There is demand, but we don't have stock. We cannot sell, right? There is opportunity, but we cannot take that opportunity, right? So if shortage cost inventory is not here, then we cannot sell. That is a storage cost, shortage cost. Inventory system. Okay. Earlier, like I said, optimal size. On average, we have 100 inventory, but we have 1,000 size of space, unnecessary, right? That also costs, right? But the other side, we need more inventory, but small space. Then we order more often, then order cost, and then moving, handling cost more like this. So using inventory system, find optimal size of inventory. There are 2 types, single period and multi-period. Single period, just a one-time purchasing decision. Decide inventory. By the way, inventory level is the same as order size. We need 1,000. Order 1,000, then we receive that 1,000. That is inventory level, right? So inventory system is the same as deciding order size. So we determine order size this time, and then order then many, and then forget it. Next time, decide again. Next time, decide again. So only one time decision, and then again and again. That is a single period inventory system. Our textbook introduced more about this single period inventory system, but I will not cover. Just to know one time, and then that's it. That is a single period inventory system. Multi-period inventory system. If we decide order size, then use that order size again, multi-period. That is multi-period inventory system. There are 2 types: fixed order quantity model and fixed time period model. Decide order size, quantity, and then use it again and again. That is fixed order quantity model. Other name, economic order quantity, EOQ. Many cases we call this model as EOQ model. Because sometimes we call this one as Q model, because we decide quantity, order quantity, so sometimes we call this one Q model. And fixed time period model. Decide the period, like every 10 days, every 30 days. If we decide the term, then the term come, then place order, and so on. That is fixed time period model. Here the name, the periodic system, periodic review system, fixed order, interval system, or P model, because we fix it at the period. Fixed order quantity model, EOQ model, or Q model is event triggered model. And then fixed time period model, or P model, is time triggered model. I will tell you why that is Q event trigger or time trigger model later. Okay, first, fixed order quantity model, Q model, determine the specific point R, reorder point. R is reorder point, the size of order Q. Using this model, we decide reorder point and the quantity, order quantity Q. Basic model, some assumptions. Demand for a product is constant and uniform. Demand is constant and uniform. That means if inventory level is Q here, then order Q and then receive Q, then inventory, initially inventory level is Q here. Then if demand is constant, then inventory level decrease like this, straight line, linear. And then lead time is constant. Lead time between order and receive. If I order today and then receive something 1 week later, 1 week is lead time. Lead time is every time the same. Then price per unit the same. Today ordered, maybe tomorrow the same unit cost, unit price. And then inventory holding cost is based on average inventory. From here to here, in this period, average inventory is right. So average holding cost is based on average inventory. Q divided by 2. And then ordering or setup cost the same all the time, and all demand for the product will be satisfied. That means place order Q, then in certain time, all demand consumed or okay. So basic model, because demand is constant and then Q is always the same, initial inventory level here, the straight line, then order receive, and then Q again, straight line, and so on like this. Because of lead time, place order and then receive the time between. we should place order this much earlier, right? So when inventory level down to this point, then place order, right? Right? So this point is reorder point. This Q model, EOQ model, this says event trigger model, right? This point R is event. So inventory level hit this point, then place on order, right? So point R is event, then hit that event, trigger the order, right? So this is event trigger model. Event is point R, reorder point. Okay. Total costs to find order quantity, we need total cost equation. Total cost TC equals annual purchase cost, annual demand times the unit cost DC plus annual ordering cost. Ordering cost. If we need 1,000 annual demand, and then if we decide order quantity equals 100, then 1,000 divided by 100 equals 10 times. To satisfy this annual demand, if Q is 100, order quantity is 100, we need 10 times of order, right? So order, this is how many ordered annually times order cost each time. So annual ordering cost is how many order, the number of order, and then times order cost. That is annual ordering cost. Then annual holding cost. Annual average holding cost is half of order quantity. Certain period average inventory level is Q divided by 2, right? So average inventory level times annual holding cost. So this is total cost, annual total cost. Using derivative, something like this, DTC over about the Q, then this. We don't care about that, right? Just care about equation. Economic order quantity Q, or we call optimal order level equals square root of 2ds, 2 times the annual demand times order cost divided by holding cost. And reorder point R equals daily demand or average demand times lead time, that is reorder point R. Bless you.
Thank you.
Okay, example. if annual demand D equals 2000, ordering cost $10, S equals 10, holding cost H equals $2.50. Then lead time L equals 7. Then unit cost is $15. Then using this formula, 2ds divided by h square root 2 times 2000 times 10 divided by 2.5 square root is 126.49. Always round up. Always round up. Even 126.1 still round up 127. Easy so far, right? And then we order point R, daily demand or average demand, annual demand divided by certain day. Because this example doesn't give you how many days, so usually 365. If question or example gives you time like this shop open 280 days, then use 280. Working 280 days, using 280 to get daily demand or average demand. So average demand times lead time L, 7 days, equals 38.36 or so, round up 39. And something total cost from total cost equation. Total cost equals DC plus D divided by QS plus Q divided by 2H. Just plug in 2000 times 15 plus 2000 divided by 127 Q times 10 plus 127 plus divided by 2 times 2.5. Then looks like this. Looking, right? Okay. Go back to the equation. Total cost equation like this. Then using a derivative about Q, then equals 0. That means if total cost curve like this, from here to up to this point, economic, this economic, right? Anyway, on this point, holding cost and ordering cost cross. That means holding cost and ordering cost the same on this point. And then this point, slope like this, and on this point, slope equals 0. So 0. Anyway, on this point, optimal order point, ordering cost and holding cost the same because they cross on that point. So if our order quantity is right, then ordering cost and holding cost the same. 157.48, 158.75. They are a bit different because we used this amount, right? If we use this one, 126.49, then they are the same because on the crossing point, right? So anyway, if order quantity is 127, total cost is $30,316.23. This should be the lowest total cost because this one is optimal or EOQ. This is basic model of order quantity model. Okay. This basic model, the assumption is constant demand, right? Constant demand, straight line, linear. But in real world, demand is not constant. In real world, demand is not constant. So, demand is slow, then it's okay. When we place order and then receive, there is stuck. But demand is more, then when we receive the order out of stock, that is problem, opportunities cost, right? So we need some safety stock in real world, safety stock. So we call this fixed order quantity model with safety stock, or just the safety stock model, because demand is not constant. Basic model and safety stock model, order quantity is the same. So you use the same formula to find the order quantity. Only difference is reorder point. When inventory level hit the reorder quantity, that is different. Because of safety stock, we need reorder point like this. Reorder point, up to this point, D bar L is basic model reorder point, right? Plus safety stock. Safety stock equals Z score times standard deviation during lead time. You know, daily demand or annual average demand, something like this. And standard deviation during lead time looks very complicated, right? Some from I equals 1 to L, standard deviation square, and so on. Looks complicated, but don't worry. Example. If daily demand is 60, this is D bar, and standard deviation is given 7 units. Annual holding cost is 0.5, 50 cents, and desired service probability. It's kind of a confidence level. If I go Walmart to buy something 100 times, if I can buy whatever I need 99 times, that store's serviceability or confidence level is 0.99, 99%. Okay, if the store wants to make service level 100%, the store need more inventory, right? So more service ability higher, then inventory level higher, like that. And then the cost of placing an order S equals 10. Then basic models and safety stock model the same order quantity, so use the same one, square root of 2ds over h. But this one gives you daily demand. We need annual demand. Again, it's like a flip over. 60 daily demand times 365. If this question gives you certain day, like a 280 work, 280 store open like that, then use that number, given number. But this one doesn't give you any day, so use 365 times 10 divided by 0.5. Here annual holding cost equals square root of 876,000 equals 935 something, rounds up 936 units. Order quantity is the same, but reorder point is different. First, we need, by the way, R equals D bar L plus safety stock. Safety stock is square root of the something something. Anyway, we need Z. Safety stock is standard deviation during lead time, Z times standard deviation during lead time is SS. Standard deviation during lead time. Something complicated, but this means standard deviation square, that is variance. Standard deviation square L many, right? From I equals 1 to L, that means L many. So standard deviation square 1, 2, 3, 4, 5, 6, because lead time is 6. Sum of 1, 2, 3, 4, 5, 6, because lead time is 6. That is the same as lead time 6 times standard deviation squared, and then square root. That is standard deviation during lead time 17.15. Okay? Then we need z-score. This one about desired service ability or confidence level. How can we find z-score? Using normal distribution chart. This attached. Desired service ability or probability 95%, 0.95. So try to find 0.95. 0.95, we cannot find the exact 0.95, but 0.95 is between 0.9452 and 0.95053, between, right? If we cannot exact percentage here, then take closer one. 0.95, right? 0.9452, 0.95053. 0.95. Which one is closer to 0.9500? How can you determine which one is closer?
Yeah.
0.95053 minus 0.95 or 0.95 minus 0.9452. Smaller one is difference. Smaller one is closer, right? So this one is closer. 0.95053 is closer. Then z-score is 1.65. Okay. 1.65. So z-score is with 95. Service probability is 1.65. 1.65. So plug in 1.65. Daily demand is given 60 times lead time 6 plus z-score with 95% of the serviceability 1.65 times standard deviation during lead time 17.15. Then reorder point with the safety stock model is 388.2975. Round off 389 units. What do you think? Doable or not doable? Okay. Any question? You don't know yet what you don't know, right? So try. Practice problem A. Try.